Welcome to another edition of ProSoft Technology video training. In this edition, I'll be setting up the MVI56E-MNET as a client server on a Modbus TCP IP network. The MVI56E-MNET client server enhanced communication module allows Rockwell Automation ControlLogix processors to easily interface with a wide variety of Modbus TCP IP compatible instruments and devices. The MVI56E enhancements include configuration and diagnostics through the module's Ethernet port, SIP Connect technology for bridging through ControlNet and Ethernet IP networks, and an onboard web server to access documentation, add-on instructions, and sample program files. In this video, I'll go over how to import the add-on instruction in RSLogix 5000, set up and configure the module in ProSoft Configuration Builder, and simulate communication with Modbus servers to ensure that everything is set up correctly. So, if you've just received your MVI56E-MNET, you might be wondering where to begin. The first thing to do is to decide where the module will reside in your ControlLogix chassis and install it. The MVI56E-MNET is hot swappable, so this can be done with the PLC powered up. Take note of the slot number that the MNET occupies, as you will need this info as you go through the setup and configuration process. With the MVI56E-MNET installed in the ControlLogix chassis, I'll open up RSLogix 5000 to configure the ControlLogix CPU. I can open and edit an existing project, or I can create a new project. I'm going to create a new project, so I'll define the processor, and Allen Bradley 1756 L55 ControlLogix processor. Select the latest revision. I'll give it a name and identify the chassis type and select the slot number that the processor occupies in the rack. And once the project is created, I'll expand the I/O configuration and right-click on the 1756 backplane and select New Module. In the Select Module screen, expand Other and choose a generic 1756 module. In the New Module window, name it MNET, and you can add a description here if you want to. It's important to set the COM format to data integer so that the module can communicate over the backplane. The slot number should be the slot that the MNET occupies in the rack, and connection parameters should be set as seen here. Next, we'll import the MVI56E-MNET add-on instruction. You can download a copy of the add-on instruction, which is a LX5 file, by going to our website at www.prosoft-technology.com. In the Controller Organizer window, expand Tasks and then Main Task, Main Program, and double-click on Main Routine. Once the main routine opens, right-click on Rung 0 and select Import Rung. Then browse for and select the .lx5 add-on rung file and click Import. When the import configuration window opens, change the slot number by modifying the local slot number field to match the number of the slot that the MVI56E-MNET is occupying in the rack. In this case, I have the module in slot 2 of the rack, so I'll change each field to slot 2. Once this is done, click OK, return to main routine, and delete rung 0. The user-defined data types imported with the add-on rung are now listed in the data types section of the controller organizer tree. Our configuration for the MVI56E-MNET should be ready to download now. I'll go up to Communications and select Who Active. And on the Who Active screen, I'll look in my Ethernet connections. locate the Ethernet module in the ControlLogix rack, open up the backplane and select the processor, and click download. And click download again on the download screen. CPU will receive the configuration, and once the download is complete, you're given the option to place the controller in remote run mode. Let's do that. If the option does not come up automatically, you just go over to the controller status bar, be sure that you're online, and select run mode. So now that the processor is configured, the next task is to configure how the module will communicate with the Modbus TCP IP devices. So to do this, I'll open up a new project in ProSoft Configuration Builder and add the MVI56E-MNET module to the project. So I'll select the default module and right-click to open a shortcut menu, and I'll select Choose Module Type, which will open the Choose Module Type dialog box. Under Product Line Filter, I'll select MVI56E, and in the Select Module Type drop-down list, MVI56E-MNET, and click OK to save the settings and return to the ProSoft Configuration Builder window. You can see the MVI56E-MNET in the configuration pane now, and if I expand it, there's a list of the MNET components. So now is a good time to give names to the project and to the location. I'll begin by clicking on the plus sign next to the module icon to expand module information. Then double-click on the module tags icon to open the edit dialog box. To edit a parameter here, just select the parameter in the left pane and make your changes over here in the right pane. The error status pointer specifies the register location in the module's database where module status data will be stored. Here, the status data will be stored at database address 4500. The read register start specifies the starting register in the module where data will be transferred from the network to the module and then to the processor. In this case, the read registers will begin on 1000. The read register count defines the total number of registers the MVI56E will write to the ControlLogix CPU. In the example, the count is set to 600 registers. The write register start defines where within the MVI56E's database the write data from the ControlLogix CPU will start. In this example, the data will begin at 0. And the write register count parameter specifies the number of registers that will be allocated to write data from the ControlLogix CPU to the MVI56E-MNET. Again, the count is set to 600 registers, and we don't need to worry about the rest of the parameters here. So when I'm done, I'll click OK to save my changes. To connect to the module via Ethernet, open up the front panel and use the Ethernet cable to connect the module config port to a switch or Ethernet hub that's accessible from the network your PC is on. Or you can connect the module directly to the Ethernet port on your PC. On the shortcut menu, right-click on the module and choose Diagnostics. This will open the Diagnostics dialog box. If you get back an error saying PCB couldn't connect to the IP address, click the Setup Connection button to browse for the module IP address. On the Connection Setup dialog box with Ethernet set as the connection type, hit Test Connection to verify that the module is accessible with the current settings. The module's default IP address is 192.168.0.250. If this isn't going to work on your network, you can assign a temporary IP address. Click the Browse Devices button to open ProSoft Discovery Service. Select the module, then right-click and choose Assign Temporary IP. In the Assign Temporary IP address pop-up, choose an unused IP within your subnet and then click OK. Use this IP in the connection setup and test connection again. If it succeeds, hit connect. Another way of connecting to the MVI56E-MNET is using SIP Connect. This utilizes Rockwell Automation's 1756E-NBT Ethernet IP module and the PLC backplane, rather than plugging the MVI56E-MNET directly into your TCP IP network. To use SIP Connect, bring up the connection setup panel and under Select Connection Type, choose 1756E-NBT. The default path appears in the text box here. Click on SIP Path Edit to open the SIP Connect Path Editor. Here you can define the path between the PC and the MVI56E-MNET. The first connection from the PC is always a 1756E-NBT Ethernet module. If the MVI56E is located in the same rack as the 1756E-NBT, then all you have to do is enter the ENBT's IP address and then the slot number of the MVI56E. Then click on Construct SIP Path and click OK to confirm the configuration path. Now click Test Connection again, and if it succeeds, click Connect. Now I can go ahead and configure the module. To make changes to the MNET Client 0 parameters, just click on the plus sign next to MNET Client 0 to expand client information, and double click on the icon to open the MNET Client 0 dialog box. As before, to edit a parameter, select the parameter in the left pane and make your changes in the right pane. And click OK to save your changes. Now I'll set up a few commands, one write command and one read command. I'll expand the Client 0 command section and double click on the icon. This will open the Client Commands Editor. And to add a command, just click on the Add Row button. And then to edit the command, double click on the row itself. So I'll do the write command first, and I'll just go down the list here. I'll set enable to yes. And for internal address, I'll leave the value at 0. Since this is a write command, and write data registers start at 0. I'll leave the poll interval at 0, and for register count I'll enter 10. No change for swap code. The node IP address is where you would enter the IP address of the device you're addressing the command to. In my case, since I'll be using ModSim to simulate a Modbus TCP server, I'll just enter my own IP address. Service port should be left at port 502. The slave address can just be left at 1. And Modbus function is where I'll enter my function code, which in this case will be 16 to write multiple holding registers. MB address in device specifies the starting Modbus register in the slave to be used by the command. And for simplicity's sake, I'm going to leave it at 0 so that it mirrors the address of the module database. And there's also a comment section where you can write a comment for the command. So now the write command is ready, and I'll quickly set up a second command to read holding registers from the server. I'll enable the command. I'll set the internal address to 1000 and set the reg count to 10. The node IP will be the same as before. I'll enter a function code of 03 to read holding registers, and the Modbus address I'll set to begin on 1000. And that should do it. To complete the configuration of the module, I'll set a permanent IP address. Go to the Ethernet settings under the module, double click and put in an IP address that your network administrator gives you.
And if you don't know what your gateway should be, just zero it all out. In order for the module to use the settings I've just configured, I'll have to download the updated project file from my PC to the module. In the tree view in ProSoft Configuration Builder, click once to select the MVI56E-MNET module, and then open the project menu and choose Module and Download. This will open the download dialog box. Notice that the Ethernet address field contains the temporary IP address I assigned earlier. This is the IP address that the PCB will use to connect to and configure the module. And since I've assigned a permanent IP address, I'll just enter it in here. And if you're using a temporary IP address, you'll just leave it as it is and click Test Connection to verify that the IP address is correct. And if the connection succeeds, click Download to transfer the Ethernet configuration to the module. And at that point, the module will reboot using the new configuration.
At this point, if everything is gone to plan, the MVI56E-MNET module should be ready to write and read data from the network. I'm going to run a test using ModSim32 to simulate a Modbus TCP server device. I'll open up ModSim32 and click on the menu item Connection Connect. From the Connect Using drop-down, select TCP Server. Now I'll go up to File and select New. Now all I have to do is switch to holding registers and change the address to 1. At this point, I'll go back to RSLogix 5000 and open up the controller tags. And under MNET, expand MNET data, write data. And under write data, the values in tags 0 through 9 should correspond to 40,001 through 40,010 addresses in ModSim. So I'll type in some values, and I can see them coming up in ModSim. So the write command is working, and now I'll test the read command. In ModSim, I'll change the address to 1001, and then starting at 41,001, I'll just write a couple of values. And these should show up in RSLogix under MNET data, read data, starting at the 0 tag. And there you have it. To test the MVI56E-MNET as a server, I'll run a test using ModScan32 to simulate a Modbus TCP client. Since the MVI56E-MNET simultaneously acts as a client and a server, I don't need to make any changes to the configuration. It should be ready to go. So I'll open up ModScan32 and click on the menu item Connection and select Connect. And on the Connection Details window, for Connect Using, I'll pick Remote TCP IP Server as the item to connect to. And then in the IP address field, I'll enter the IP address of the MNET module that I assigned in PCB. The service port stays at 502, and I'll click OK. At this point, I can see that valid slave responses are increasing along with number of polls, so I know that the simulator is working. And I'll switch to holding registers, and I'll take a look at address 40,001, which corresponds to write data section of the MNET's database. I'll jump back to RSLogix, and I'll enter some values for the write data tags.
And I can see that those values are showing up in addresses 40,001 through 40,005. So the write commands are working. And I can test the read commands by switching address to 1001 and entering a couple of values into addresses 41,001 and 41,002. And I can see the values have been entered in on read data 0 and read data 1. So the read command is working as well. One thing to note is that the MVI56E-MNET server and client functions share the same database. So if you're not careful, it is possible for one to overwrite the other if they're both using the same addresses. So keep that in mind. And that does it for this training session. I hope the video series has been helpful. And as always, if you have any questions, don't hesitate to give us a call. Happy training.